In chapters 4 through 6 of Extending Children's Mathematics, Fractions and Decimals, Empson and Levi delve deeper into understanding relational thinking and how to effectively nurture students' intuitive sense of fractions and algebra in the classroom. Relational thinking strategies are represented by the self-generated strategies children use when exploring mathematical relationships. Often these strategies represent higher mathematical concepts and equations, although the children have not been explicitly taught this information. For instance, on page 77, we see an example of a third grader strategy for solving 5 times 14. The student determined that 5 groups of 10 and 5 groups of 4 would be akin to 5 groups of 14. By decomposing numbers into more easily digestible multiples, the student used the distributive property without ever having heard the term before. Similarly, a sixth grader solved this problem using the associative property of multiplication without ever having been explicitly taught the concept. He simply reasoned 10 was twice 5, so he could have 14 and find that 5 times 14 is equivalent to 10 times 7 and therefore 70. Despite children's intuitive understanding of these concepts, teachers still play an important role in curating and strengthening students' exploration. Evidence shows that without teacher guidance, the ability to think relationally becomes stunted and atrophies. By high school, many have lost the ability to reason out a mathematical equation. For many teachers, however, understanding their role in relational learning can be confusing. As such, Chapter 5 of Extending Children's Mathematics relates a play-by-play of a typical relational lesson in Ms. Perez's 5th grade classroom as an example of appropriate explicit instruction for relational learning. Here, Ms. Perez presents the students with the problem. Mr. Davis is planning an art project for his class. Each student will need 3/4 of a package of clay to do this project. If Mr. Davis has 12 students in his class, how many packages of clay would he need? Ms. Perez provides each student with a paper and asks them to solve in whatever way makes sense to them. Her work does not end there, however. She monitors the class, checking independent strategies and prompting those who are struggling. As she views strategies, she looks for evidence of relational thinking and finds 2 students who have solved the problem with deeper strategies, although they have some trouble expressing it on paper. Once the class has worked on solving the problem for 20 minutes, Ms. Perez consciously selects students to share their strategies. She starts with Alex, who has used the more basic strategy of adding and drawing a picture, then scaffolds her lesson to introduce student strategies that show deeper thinking. As students relate their strategies, she prompts them to create equations to express their thought process and encourages others in class to question and explore these answers and how they relate. Eventually, the class is engaged in a lively discussion, and it becomes clear that many are grasping the more advanced strategies used and how to express it as an equation. As we can see, an effective teacher is still necessary to help students communicate and express their thoughts and bridge the connections between relational and more basic strategies. In Chapter 6, Empson and Levi discuss relational strategies to heighten students' understanding of fraction equivalence and order. They advise against the use of manipulatives when introducing this concept, as often children's understanding of what looks bigger has no relation to mathematical understanding of the concept. Instead, they insist children should be supplied with paper, a pencil, cut out pieces of paper, and colored pencils or markers. When armed with these tools, students can tackle an equal sharing problem to understand equivalent fractions. For instance, a teacher may present students with the problem. 6 children have ordered blueberry pancakes at a restaurant. The waiter brings 8 pancakes to their table. If the children share the pancakes evenly, how much can each child have? Some may partition the remaining pancake into thirds, some into sixths. This generates discussion of what is more, less, or equivalent. The teacher should monitor and proctor discussion to foster student understanding. Again, I found Empson and Levi's text to be extremely informative and helpful in constructing ways to create a positive and effective classroom for math learning. As evidenced by numerous texts throughout this semester, incorporating relational learning into the classroom is an important tool for creating a sustainable mathematical environment. It enhances children's understanding, and many indicate enjoying math more as a result. This text is an important resource to understand children's rationalizing and how to best approach relational learning in the classroom.